A few years ago, I posted a video about this math problem. AA plus BB plus CC equals ABC. Solve for A, B, and C. Each is a positive whole number. I've included a link to that video in the description, and my video was inspired by the same problem presented on the YouTube channel Mind Your Decisions. I had come up with a different solution, and I encourage my viewers to share their own solutions. One of my viewers left a comment with a very simple solution that started off in the same way as the Mind Your Decisions solution, but I think was more efficient, and I was inspired to create a new video that demonstrates that solution. In addition to that one, I'm going to show a third solution. If you haven't tried to solve this before, go ahead and pause the video now and give it a try. Otherwise, I'm just going to go straight into the solution. All right, so the solution that was in the Mind Your Decisions video makes a pretty obvious observation about the ones column. So we can see that the ones unit of A plus B plus C must equal C. So A plus B must then equal 0 or 10 or 20 or 30 or 40 or 50 as long as the ones unit is 0. But A plus B can't equal 0 because A and B are both positive whole numbers. And it can't equal 20 because at least one of them would have to have 2 digits. For example, if A is 9, then B would have to be 11, and 11 is not possible. The possible values are 1 through 9. So A plus B can't equal 0, can't equal 20 or 30 or 40, it must equal 10. This is a straightforward conclusion. Now we can also conclude that A plus B plus C must be less than or equal to 19, and the reason for that is if A plus B equals 10, and the maximum value of C is 9, then the maximum possible value of A plus B plus C is 10 plus 9, and that's 19. Now this is important when we look at the tens column. Because A plus B plus C cannot exceed 19, then we know that we get to carry a 1 to the tens column. So where in the ones column we saw that A plus B plus C equals C, in the tens column we see that A plus B plus C plus 1, that 1 that we carried, equals B. So A plus B plus C equals C, and A plus B plus C plus 1 equals B. We can rearrange that as C plus 1 equals B. Now we can conclude a few other things. First, C must be less than or equal to 8, and that's because the maximum value of B is 9, and C is less than B. And then we can adjust this equation. A plus B plus C plus 1 must be less than or equal to 19, and this comes from the observation that A plus B equals 10, C must be less than 9, and then we add the 1. This becomes important when we look at the hundreds column, because again, we get to carry a 1. Now here, we don't have A plus B plus C in the hundreds column. It's just that carried 1 equals A. So we already know that A must equal 1. And if you remember A plus B equals 10, we know that B must equal 9. And if you remember C plus 1 equals B, we know that C must equal 8. And this gets us to our solution. Solve for A, B, C, each is a positive whole number. Well, A equals 1, B equals 9, and C equals 8. Go ahead and do that on a calculator. You'll see it adds up. Now I'm going to go to my second solution, which derives from a simple observation here. We can rewrite this as 11a plus 11b plus 11c, so 11 plus 99 plus 88 equals 198, where that's 100a, 10b, and c. So here's how that looks. 11a plus 11b plus 11c equals 100a plus 10b plus c. I'm going to do a little bit of simplification. I'll start by subtracting 11a from both sides. That gets us here. Then I'll subtract 10b from both sides. That gets us here. And then finally, I'll subtract c from both sides. So we end up with b plus 10c equals 89a. Now, I'm going to try to figure out what's the maximum possible value of b plus 10c. One way or the way to do that is to set b and c both to 9. So if b is 9 and c is 9, it would be 9 plus 10 times 9 equals 89a, or 9 plus 90 equals 99. So 99 is the largest possible value of 89a. Now let's plug in some values of a and find out if they are possible. So for example, if a equals 1, then 89a equals 89. That is smaller than 99. So this is a possible value. If a equals 2, 89a equals 178. This value is not possible because it's larger than 99. We see for values of 3 and 4 and 5 all the way up to 9 that it results in impossible values. So we can conclude then that for b plus 10c equals 89a, a must equal 1. So b plus 10c equals 89. Now I can rewrite this equation as 89 minus 10c equals b. And now I can plug in values of c and see if they produce valid or possible values of b. So let's start with c equals 9. That would be 89 minus 10 times 9, or 89 minus 90 equals negative 1. Negative 1 is not a possible value of b. If c equals 8, then it's 89 minus 80, and that equals 9. 9 is a possible value of b. If c equals 7, then it's 89 minus 70 equals 19. 19 is not a possible value. For 6, it's also not a possible value. 5, 4, 3, 2, 1. We end up with impossible values. So we can conclude that c must be 8. So we end up with b plus 80 equals 89. And we already know from the equations on the screen that b must equal 9. So we swap that out. And what we see here is the same solution. A equals 1, b equals 9, c equals 8. Let me know if you came up with a different solution. One of the things I like about this problem and so many math problems is there are multiple ways of solving them. There isn't one correct answer. Yes, absolutely, there are much simpler answers. There are answers, or there are solutions that get to the answer more quickly than others. But there are so many different approaches to solving this, and I think that's one of the interesting and fun things about math. So yeah, let me know if you found something different. Let me know what you thought of this. Hope you enjoyed watching it.